first illustrate the motorcycle stunt rider on top of a building traveling at a speed of 5 meters per second. This 5 meters per second is the horizontal speed. So by the time the motorcycle stunt driver reaches the edge of the building, it will have to follow this trajectory, which is projectile motion 1. In this problem, we are asked to solve for two quantities. First, the position and the velocity. Let us first solve for the velocity of the motorcycle stunt driver after 1/4 of a second. So somewhere along at this point. So at this point, the v sub x remains the same at 5 meters per second, and the v sub y, we have to solve for that. To solve this, we make use of the equation Vf is equal to Vi plus Gt. And we know that initially, there is no y component for the y-axis. The v sub I is equal to 0. The g is negative 9.8 meters per second squared. At this point, it took 1/4 second, 1/4 of a second, 0.25 seconds. So somewhere here, the speed will be 2.45 meters per second. We can now solve for the resultant velocity. Using the Pythagorean theorem, you have v sub r equals the square root of v sub x squared plus v sub y squared. V sub x squared is 5 squared, and then v sub y is 2.45 meters per second squared. Solving for v sub r, you will get 5.56 meters per second. And rounding off, we will have 6 meters per second. 6 meters per second is just the magnitude, so we have to solve for the direction. Using theta is equal to the arctan of y over x. Theta is 26.10 degrees south of east. So we are now done with the velocity. We now solve for the position of the rider after t is equal to 0.25 seconds. For the position, we have to solve for d sub x, and we also have to solve for d sub y. D sub x is given by this equation, v sub xt, and the v sub x, even up to this point, is 5 meters per second. Multiplied by the time. It's given at 1/4 of a second or 0.25 seconds. We will get 1.25 meters. The d sub y, we can solve this using VIT plus 1/2 GT squared. And we know that initially, there is no y component, so this is equal to 0. So 1/2 g is negative 9.8 meters per second squared, and the t is 0.25 seconds then squared. The d sub y will be 0.30625 meters. Again, we have dx and dy. We can now solve for the resultant displacement, which is also our position. So d sub r is equal to the square root of dx squared plus d sub y squared. Our dx is 1.25 meters, and our d sub y 0.30625 meters. On solving, you will get 1.159. Rounding off to one significant, you have 1 meter. We now solve for the position. Theta is equal to arctan of y over x. Y over x. So 0.30625 divided by 1.25. Our theta is 16.17 degrees south of east. This is the direction for our displacement. Okay, so we have 6 meters per second for the velocity, and for the position, you have 1 meter. Remember, the position or displacement is the straight line distance from the starting point up to this point, 1/4 of a second.